Hello, my name is Haris Fayan Bakri and I'm from Group 15 and this is my teammate Muhammad Zaidi bin Ibrahim and Muhammad Izzat bin Muhammad Samsudin. So our group use tire rim as our parts in our project. So what is important of this part? So this part is used in vehicles and vehicles used for transporting and traveling and transporting and traveling. Um, Almost all land transportation use this part. So this part is quite important as it gives traction and for stopping vehicles. It also supports weight, absorb shock, and for changing direction. So our project is to analyze this part on two load cases. So our objective is to carry out finite element analysis on this tire for two load cases and to examine the structural performance of the tire rim for stress distribution and deformation of the component. So I'm giving my teammate to present both case load.
I'm going to explain the load case 1, which is the load on the contact patch between the tire and the ground. So as you see in the figure on the left, the reaction from the ground will causes from the bottom one. Then we can assume the car on static. So there will be other forces acting on it as you see in the purple arrow. So on the right figure, you can see the red arrow direction on the downward. It is indicating the gravitational acceleration 9.1 meter per second square. Then the green arrow on the each 5 circle on the right figure here. So we can see that it is indicated that was a fixed geometry. So next, so this is how we calculate the reaction force. So the first step is we have to find the mass of each tire. The most of the vehicle have 4 tires, but we only need 1 tire to be observed in this case. So the formula for the mass of 1 tire is 21% of the curb weight of the vehicle. But what is curb weight? Curb weight is the weight of a vehicle with a fuel, oil, and coolant, but without occupant, luggage, or cargo. It is only weight of the just vehicle only. So in this case, we take 1044 kilogram is a curb weight that we find based on Honda specification book. So using the formula, we can say that 21% of 1044 kilogram is 219.4 kilogram, which is the mass of a single tire. So this single tire, next, we have to multiply it with a gravitational acceleration to obtain the reaction forces, which is 2150.7 Newton. Then this value will be the input for our FEA analysis. The first analysis is analysis based on stress distribution, von Mises stress gradation. So as you see in figure on the left, most of region were in blue that indicate the tire is having low stresses. The lower stresses can we see on the outer section of the rim with only 99.02 kilopascal. The maximum stresses is on the central spoke with 1672 kilopascal. Since our selected material for the rim, which is alloy steel, have yield strength of 920.4 megapascal, which is larger than with our maximum stress, so this rim will not fail. Next, analysis based on displacement distribution. So after the load apply on the tire, the this one will cross the displacement. As we see in a figure in the middle, the minimum displacement is very small on the central of the rim with one exponent negative 30 meter 30 meter. Then the maximum displacement is on the top right of the rim with 1.681 millimeter. Since the displacement is not really high, the shape of the tire still can maintain its shape when the loads acting on it. So the last analysis for the test load 1 is analysis based on safety factor. The minimum safety factor is 371 on the middle top left stocks, and the maximum safety factor is 9.69 9.6.969 exponent 5. So since both of this value is more than 1, we can say that the tire is totally safe when the loads acting on it.
Alright, so for my podcast load number 2, I did the analysis on the pressure distribution across the circumferential area of the rims. So there's a few keynotes that we need to know that I've chosen the value of the pressure 35 psi, and I also choose the material of these rims to be aluminum alloy 6 or 61, and I also consider the gravitational effect on this rim, which is represented by this red arrow, and the pressure is represented by the orange arrow. Why is the pressure is distributed balanced around the circumferential area? Because the load and the weight of the car did insignificant effect on the car pressure between maybe 1 or 2 psi based on my research. So for the second picture, I represent the green part of the lock holes as the fixed geometry where we want the part to not move and attach on the car. Alright, so for the first analysis, based on the stress distribution, Born-Meister stress criterion, we can see the maximum stress, which is 7.72 megapascal, and also the minimum stress, 7.697 exponent negative 3 megapascal. This is because of the cross-sectional area of the rims. As you can see, the thinnest part of the rim, which is the spoke, the thinnest part of the spoke of the rims have the maximum stress, and the thickest part of the rim has the minimum stress distribution, as represented by this gradient of color. As for the second analysis, displacement distribution, it is different part of the rim compared to the last one. Uh, so uh, the maximum displacement are 7.5 exponent negative 6 meter, and also the minimum you maybe cannot see clearly because the the recorder is blocking the picture, but I will tell you the value. Minimum displacement is 1 exponent negative 33 meter. So this has to do with the pressure, the distance from the pressure of the tire, As you can see, the circumferential area has the maximum, the closest to the pressure, the maximum displacement value, and the furthest from the pressure are not affected by the displacement is not affected by the pressure of the tire, which has the least needed slug holes. As for the last analysis based on the safety factor, as you can see, we have the maximum and minimum safety factor. This has to do something with the material of these rims. We choose the material as aluminum alloy, which has the yield stress of 620, and also from the previous stress analysis, as you can see on this analysis, one minus stress criterion, we have the maximum value of stress to be 7.72 megapascal. So dividing the yield stress with the maximum stress on the rim, we get the safety factor. So this value is representing that this rims is very safe, which is the value is far from 1. And if you want this rim to fail, maybe we have to change the material or increase um, a very significant value of pressure on this rim. So I guess that's it. We move on to the next one.
So as for conclusion, for both cases, the amount of load exerted on the rim are not even close to uh, to make the rim fail. At least while it is not moving and not causing the load to be much higher. So probably that the current cases for this rim to fail is from uh, other such as oxidation that may cause rusting, or it also can cause by corrosion and others uh, effect.